Hello, and welcome to Lab 1, Dimensional Analysis and Calculations. Units and values. All physical measurements consist of two basic parts, values, or quantities, and units, or unit of measure. Values are meaningless without units, and units are meaningless without values. So throughout this course, you will need to understand how to correctly convert units, and all lab questions answered without proper units are marked incorrect. Unit conversions. Conversions are completed by using conversion factors. For example, 4,000 meters may need to be converted to 4 kilometers using the conversion factor of 1,000 meters equals 1 kilometer. The mathematics for this conversion are called dimensional analysis. Dimensional analysis. The process of dimensional analysis, also called unit conversion, is a mathematical method of multiplying ratios to convert from one unit to another without changing its value. In the introductory video for Lab 1, we introduced dimensional analysis using the example of converting 14 meters per second to statute or standard miles per hour. We begin with the initial ratio of 14 meters per second. Next, determine the unit conversions needed. In this example, we must convert meters to miles and seconds to hours. Let's start by converting meters by using the ratio of 1,000 meters to per kilometer. By replacing 1,000 meters in the denominator, we're able to cross-cancel meters. Next, if we multiply by the ratio of 1 statute mile per 1.6 kilometers, we can cross-cancel kilometers, leaving standard miles in the numerator, which is the proper format of our final answer. Now, let's convert seconds by using the ratio of 60 seconds per minute and then cross-cancel seconds. Finally, if we multiply by the ratio of 60 minutes per hour and cross-cancel, this will result in hours remaining in the denominator, again, which is the proper format of your final answer. Now, if you multiply all values across the top and then divide by the product at the bottom, your final answer will be in the units of statute miles per hour or miles per hour. Next, let's walk through a few examples of dimensional analysis to learn how this process works. Example 1, how many meters wide are the Straits of Gibraltar? If they're reported as 9.6 miles wide, we'll assume statute or standard miles. You may have noticed that dimensional analysis follows a basic 3-step process. Step 1, state the problem. Here we want to determine that 9.6 miles equals an unknown quantity of meters. Step 2, identify the unit conversions needed to change meters to miles. The conversions are provided below. Throughout this course, your lab TA will ensure that all unit conversions are provided. And finally, step 3, unit conversions. Multiply your initial measurement by the necessary conversions such that the undesired units cancel out, leaving only the desired units. To do this correctly, it helps to look at a conversion factor as ratios. Specifically, notice that 1 statute mile per 1.6 kilometers is the same as saying 1.6 kilometers per statute mile. Or for example, 1 kilometer per 1,000 meters is the same as saying 1,000 meters per 1 kilometer. Stated either way, these are equivalent units. When setting up your ratios, ensure that your units cross-cancel in a way that only leaves the desired units. Setting up conversions in this way provides a strong check of your work. If you did it correctly, after cross-canceling, you should be left with only the desired units of meters. Example 2, convert a wind velocity of 30 miles per hour to meters per second. In this example, there are 2 types of conversions, distance miles to meters, and time, hours to seconds. Given the following conversion ratios, follow the three-step process to calculate your final answer. Feel free to pause the video now if you'd like to try and solve the problem on your own first. Welcome back. If your dimensional analysis was correct, you should have calculated 13.41 meters per second. It's now time to complete your lab assignment. To receive full credit, make sure to show all of your work, include all units, and clearly mark your final answers. Also, round your answers to the nearest tenth. After completing dimensional analysis and calculations, watch video 3, part A1, Major Oceans and Latitude and Longitude. Please address your questions to your lab TA.